This video is based on the specification limits, natural tolerance limits, and some concepts which were left over in the previous video. The specification department says this can be the maximum value of x and this can be the minimum value of x, the upper specification limit and the lower specification limit. And these are the estimates of mu cap, which is x bar. When you are using R chart, the estimate of sigma cap is R bar divided by 2. And when you are using S chart along with the x bar chart to analyze the process variability, the estimate of sigma, that is standard deviation, is S bar divided by C2. The natural tolerance limits are nothing but 3 sigma limits. So what will be the width of 3 sigma limits? 3 sigma above and 3 sigma below, together width will be 6 sigma. If your specification range, that is x max minus x min, is greater than the width of the natural tolerance, it means that your process is generating good products. Okay, so when the specification band is greater than natural tolerance band, it means that you are generating good products. When they are equal, when the range of specification limits and the range of natural tolerance limits are equal, it means that the process is exactly meeting the specifications. When it is less, that is when natural tolerance limits are greater than the specification limits, it means that a slight shift in the process will increase the fraction defectives. Okay, will increase the fraction of defectives. Right. So let us go into the today's questions. Identify the situation in which C chart should not be constructed. The purpose of C chart is to test whether the number of defects per unit are in control. Number of imperfections in a bale of cloth, you can construct C chart. Number of black spots in a roll of paper, you can construct C chart. Number of defects in an aircraft component, you can construct a C chart. Number of defective items produced, for this you can construct P chart or D chart. You cannot construct C chart. Okay. Which of the following is the range of specification limits? Minimum value plus maximum value? No. Maximum by minimum? No. Maximum minus minimum. Okay. Right. The natural tolerance limits are 3 sigma limits, or 2 sigma limits, or 1 sigma limits, or 6 sigma limits. 3 sigma limits are the natural tolerance limits. The width of the natural tolerance limits is 6 sigma. When can we say that the process is too good? When the specification limits are greater than natural tolerance limits. See here, x max minus x min is greater than natural tolerance limits. Here you can say that the process is too good. When can you say that the process is exactly meeting the specifications? When the specification range of the specification limits is equal to the range of tolerance limits, you can say that the process is exactly meeting the specifications. If the range of specification limit is less than 6 sigma, which of the following is false? Natural tolerance limits, this is greater than specification limit, this is true. A small shift in the process will decrease the fraction defectives, this is false. A small shift in the process will increase the fraction defectives, this is true. So which is false? B is false. Even a slight difference will increase the fraction defectives when the specification limits are within the natural tolerance limits. What is the estimate of sigma based on R range? This estimate of sigma based on S is S bar by C2. When standards are not given, you should use P bar, right? The control limits for fraction defectives are P bar plus or minus 3 into square root of P bar Q bar by N, P bar plus or minus square root of P bar into 1 minus P bar by N, P bar plus or minus A into square root of P bar Q bar. What is A? A is 3 by square root of N. So all are the same answers, all of the above.